All right. Now we're going to start learning about the special angle pairs. So 3 special angle pairs we're going to learn about today. There are others that we'll learn about in the next video. But this time we're going to learn about, adjacent angles. Adjacent is a word that you may or may not know, but it means next to. So if I were to put that in there, next to. Kind of like your neighbor, right next door. So our 2 angles that lie in the same plane, they have a common vertex and a common side, but they have no common interior points. So if you think about neighboring things, if you lived in this house, this is your house, and your neighbor right next door would be right here. They would be your adjacent neighbor, okay? But if this is your street, the one across the street would not be your adjacent neighbor. The one over here would not be your adjacent neighbor. The one down here would not be your adjacent neighbor. Only the ones on either side would, because they share a common vertex and a common side. If that makes sense. So I don't know if that makes sense in your mind, but in my mind it does. It's your right next door neighbor. So in these examples that they show of the angles, here's your common vertex and your common side right there. So angle 1 and 2 share that common side. And then they each have their own side going off of it. Now these ones, even though they appear like they're next to each other, they have their own vertex. See, 2 unique points. And they have 2 unique sides. You can draw them independently, therefore they are not common. Okay, non-examples there don't work. Okay, linear pair. A linear pair has that word line in it, line. That means they are on a line together. A linear pair is a pair of adjacent angles. So now they are also adjacent angles. They have a non-common side and they are opposite rays. So they've got a couple things going on there, adjacent angles and opposite rays. So they make a line and they share a common side. Oh, there's a bell. All right. So the sum of the angle measures is going to always be 180 degrees. So in our examples here, 1 and 2 are a linear pair, and they will add to 180 degrees. So 45 plus 135 equals 180. In this non-example, these are adjacent angles. They have a common side and a common vertex, but you can tell that they're not a linear pair. They are not going to add to 180 degrees right there. Okay. Now vertical angles. This is a new term that probably you're hearing for the very first time. We're going to use this term a lot. A lot. So get used to this term. Vertical angles are 2 non-adjacent angles formed by 2 intersecting lines. Intersecting lines are aligned, so you got one line going one way, right? And then another line comes down through it. One moment. Okay, so another one's coming down through it right there. All right. And then the vertical angles are the non-adjacent ones. So adjacent ones would be like this one and this one, right? Or this one and this one. So the non-adjacent ones are going to be when you skip one. So you go there, you skip that one, and you go to this one. That's what non-adjacent ones. They're the ones opposite each other. They're the ones across from each other. And here's the big kicker. Vertical angles are always congruent. That's really cool. Vertical angles are always the same measure. So if we look over here and we number all of our angles, 1, 2, 3, and 4, that means that angle 1 and angle 3 are the same measure. And angle 2 and angle 4 are the same measure. And that's what they marked down here. 1 and 3 are vertical, 2 and 4 are vertical. And they could even go further and they could write it out like this. Angle 1 is congruent to angle 3, and angle 4 is congruent to angle 2. And that rule right there allows us to do a lot of really cool things with math later on. So hang on to that one, stick it in your back pocket. Really helpful. This is a helpful rule. Okay, non-example here. These are not intersecting because they are not straight lines. Therefore, not vertical lines, or not vertical angles, not vertical angles. So we can't count them as congruent, can't use the rule, okay? There you go. All right. So let's use this as an example. The office lamp is made using 2 intersecting metal bars. How many pairs of adjacent angles do you see in the figure? List 2 pairs. Well, we've got the 2 lines here. Then we've got this angle with this one and this angle with this one. And if we listed out those angles, then we would have, let's see, ABE. So that would be angle ABE is congruent to angle DBC. And the funny thing is when I erase those and then I start highlighting the other ones, it'd be DBA. Angle DBA is congruent to EBC. Looks like we've highlighted the exact same, or EBC, sorry. Angle EBC or CBE, doesn't matter. Looks like we've highlighted the same things, but they were highlighted differently. So there we go. There's our 2 pairs of vertical angle pairs. Okay. Oh, sorry. I was looking for vertical angles because I was so excited. Those go right there. All right, sorry about that. There was an announcement in which you guys have to listen to the whole thing. All right. Oops. Went out of order there. Okay, how many pairs of adjacent angles? Adjacent angles do I see? So adjacent is those next 2 ones. So we're going to go ahead and look for a common line. So if I pick a common line and a vertex, then I see like these ones. Okay. So that's 1 pair. Next 2, I could pick and then go 1, 2. So that's another one. Could do these ones. That's 3, 4. So I see 4. I see 4 pairs. And if I list out 2 of those, let's see, I'm going to do this one and this one. So angles EBA is congruent to angles DBA. Again, order doesn't matter except that the vertex has to be the middle point. And then I will do, we'll do EBC and CBD there. So angle EBC is congruent to angle CBD. There we go. How many linear pairs do you see in the figure? List each pair. Well, if I look at this, because these are all lines, I see a pair that makes it that one. And out that way, so that's another pair. So that's 2. And then I see another line here, so I see a pair that makes it that one. And there, so another 2 there. So I see 4. I'm not going to list all those. You may go ahead. And then this one says, find the measure of EBC. Now this I love, so I'm going to go ahead and make myself some space. Let's see here. Find some measures. So let's look at this guy. If this is 138, let's solve some of these measures. If that's 138, how big is this one? Well, if they are vertical angles, and we know vertical angles are congruent, then that must be 138. And then we ask ourselves, how big is this one? Well, if this is a line, and all lines are 180 degrees, then this one plus this one must be 180. So if we give that, we could even give it a variable. We could say 138 plus x must equal 180. And if we subtract our 138, x must be 42. So this is 42 degrees up here. Go ahead and erase our x in there. Put that down. And these two are vertical angles also, so this is also 42. So now we've solved all of our angles, so now we just go back and say, what is EBC? That's the question they had for us. EBC is, right, let's see, erase this highlight. EBC is this angle. Oh, that's 138. And ABE is over here. That's this angle. That's 42. There we go. So I walk through solving all those. We got those. Can vertical angles also be adjacent angles? So can a vertical angle also be an adjacent angle? So could this set of vertical angles also be next to each other? No. Because adjacent angles would be like here and here. Nope. Okay, so you go ahead and practice. Take a stab at this and pause me. Did you get A and C? All right, now go ahead and practice these ones.